We're here at our final type of stoichiometry, solution stoichiometry. Here's a practice question that we can do together so you can kind of see how these types of stoichiometry are the same. Just in terms of that they follow the same rules, and I've hopefully established that so far throughout the clips and videos that I've made. First of all, again, reading the question, I get my balanced chemical equation. So here it is, just an acid-base reaction, a neutralization reaction of sodium hydroxide and sulfuric acid. So it's a double replacement that I've written here, balanced it out properly. I've also identified what my given and what my required is. The question says, what was the concentration of sulfuric acid? That's this over here. Then I know that that's my required. So my concentration is what my unknown is, and I'm going to stick in my volume underneath of that. You can also see that the question gives me the volumes in milliliters. You have the option here to change them to liters. It helps a little bit, I think, with kind of canceling the units out. I'm going to show you both ways. I personally like to leave the milliliters as milliliters. I think it's one or two more steps that you're adding in where you could potentially make a mistake. Oftentimes I see kids make this mistake where they convert 20.5 milliliters into liters and they forget this 0 right here as a placeholder. Changes their number by a factor of 10 and they end up getting the wrong answer because of it. So I like to leave it in milliliters. My next example will show you how to do that. But this one I'll show you how to convert the numbers, and you can choose which way is most comfortable for you. So step 1 is done. I've got a balanced chemical equation. Step 2, calculate the moles of the given. So here's step number 2. The only thing that's different here is how I'm calculating the moles of the given. In gravimetric stoichiometry, how I do it is I use a mass and a molar mass. In gas stoichiometry, I might use a mass and a molar mass, or if I'm given a volume, I would use pressures and temperatures and the ideal gas law to do that. For solution stoichiometry, I could use a mass and a molar mass. If it gives it to me, in this question it doesn't, so in this case I'm going to use liters and moles per liter to get my moles of my given. And so in this case you can see again, liters cancel with liters. I'm left with moles of my given, which is moles of sodium hydroxide. Step number 3, convert the moles of the given into the moles that are required using the mole ratio. So there's step number 3, my mole ratio of required over given, with these coefficients being used, 1 mole over 2 moles. And then this last step right here is a little bit tricky in that you have to make sure that you're paying attention to what's canceled and what hasn't been canceled yet. So you can see the moles here cancel, and so I'm left with moles on the top. Now the question is asking for concentration in moles per liter. So I already have moles on the top, and the only number I have left is liters. So I have moles, I just need to go per liter by dividing by the liters, and that will give me my answer. So I don't want to add anything else on the top, so I'm just going to put a 1 on the top so it doesn't change the answer that I'm getting here. And I'm just going to divide by how many liters I have in the question, which is 0.0205 liters of sodium hydroxide solution. And then you can see I've got moles per liter of sodium hydroxide. That NaOH canceled out over here. And you plug this into your calculator and you end up with 0.37 moles per liter. I'm rounding this to 2 significant digits because if you'll notice in the question it gave me a concentration of sodium hydroxide only to 2 significant digits. Yes, these numbers here do have 3 sig digs, but because this one has less, it's only got 2. That's the limiting factor I have to work up to. I can't go more than 2 with my answer because of that. So 0.37 moles per liter. That's the first example, guys. Be right back with the second one. So we're here with our final example of solution stoichiometry. Again, you can read through this. I'm not going to read it for you, but you can pause the video, read the question, and make sure that I've got my balanced chemical equation right. The biggest thing here, guys, is that you're making sure that you know how to write chemical reactions, making sure that you can predict the products properly and that you are writing the proper ratios of things as you're writing them down so that you can balance the reactions properly as well. Oftentimes I do find that one struggle kids have if they really struggle with stoichiometry is they really struggle with this first step. And this is why we made this review at the beginning of Chem 20. So hopefully you remember this. If you are a little rusty with the review and you need some extra help with that, then you need to spend some extra time reviewing things like how to write chemical reactions. So I've got my balanced reaction here, and again, the steps to stoichiometry are the same. Step number 2, calculate the moles of the given. I've done that here. Making sure that I've got my volumes canceling, one on the top, one on the bottom, and my moles are left on the top. Then I convert that into the mole ratio, or using the mole ratio into the moles that are required, and then I've got my concentration over here on the other end. Now, the thing that you'll notice here with this is that as I'm writing this and canceling this out, the way that I'm kind of looking at this in terms of canceling, and so I don't have to convert my milliliters into liters, is I just leave my number as milliliters in the question, and then I can cancel it this way. So I can see that my moles cancel like this, and I want to cancel out my concentration. So my concentration is set up like this with moles per liter, and the reason I've done it like this is so that my liters can cancel my liters, but notice that I'm left with milli still. So my answer here, if I were to write it down, would be millimoles. And so then I look and I can see, okay, my moles cancel with those moles, and I've arranged this number such so that the moles do cancel with those moles. But notice now my units left over are just milliliters again. And so I cancel it out that way so that I don't have to do any extra converting that I don't need to. It's less places where I can make an error. I can just analyze the units and not have to worry about, did I make a calculator mistake, or did I miss a zero somewhere in my numbers as I was jotting them down on the page. It just helps me with sort of monitoring and managing how many errors and places I can make errors when I'm doing these problems. So my answer punches out as 28.0 milliliters of sodium sulfate to solve the question, where it said what was the volume that was required to make this reaction occur. And so that's what I end up with for that. What you also notice with these types of questions too, with solution stoich and gravimetric and gas stoichiometry is, and we saw this a little bit with gas stoichiometry, is that these types can kind of be merged together a little bit. So we can kind of get like mixed stoichiometry types of questions where maybe I have to do a little bit of gravimetric at the beginning, dealing with masses and molar masses, and then I've got to deal with some volumes and concentrations at the end, a little bit of solution stoichiometry. Remember that the steps to stoichiometry are the same no matter what. Just follow the steps, and whatever numbers you have are the numbers you have to work with in order to solve that step for that particular stoichiometric question. So hopefully this has simplified things for you guys. And if you have any questions, or maybe things are a little bit fuzzy, don't hesitate to go back and re-watch some of these videos. As many of the problems and mistakes that kids tend to make, I've tried to cover in these videos. So a watch through a second or a third time is helpful to make sure that you're catching all the things that you need to be doing to do these right. So that's all I got for you on this one. Thanks for watching.